And now I substitute, instead of VCM, I will put omega r, but r is this distance. So I will put 1/2 n omega d squared plus 1/2 this mi/ri squared is the moment of inertia of the center of mass. mi/ri squared is the moment of inertia of the center of mass, which is this formula. It's the total moment of inertia of all particles. So that is the moment of inertia of the center of mass. Time omega squared. If I factor out omega squared, I get that 1/2, and I get now ICM plus nd squared times omega squared. So what will be I of my arbitrary axis? This is I of with respect to the arbitrary axis. What will be? Is the moment of inertia of the center of mass plus the mass times the distance from the center of mass to the axis of rotation, mv squared. This is how to get the moment of inertia of when the object is rotating with respect to an arbitrary axis. For example, and I will give an example now. This is what we call parallel axis theorem. So when we will use the parallel axis theorem? When the object is rotating about an arbitrary axis, so not the center of mass. Let me just put it this way. So the parallel axis theorem says that I arbitrary is equal ICM plus nd squared. This is to find the moment of inertia when the object is rotating with respect to an arbitrary axis. For example, let's say a rod is rotating with respect to here. With respect to, I am here, this is a meter stick. So let's say that the rod is rotating with respect to the point 25 here. This is an arbitrary axis. So if I want to find the moment of inertia, what should I do? According to the parallel axis theorem, if this is rotating with respect to 0.25, this is a meter stick. So I am rotating with respect to this, which is 1/4, 0.25 of the length, meter. I want to get the moment of inertia, but because the rod is rotating with respect to here, I know already the moment of inertia with respect to the center of mass. And I know with respect to the end, but I don't know with respect to an arbitrary axis. So if I want to find, I have to use the parallel axis theorem, which is ICM. What is ICM for the rod? ml squared over 12. So if I want to find the moment of inertia here will be ml squared, which is 1, over 12, plus what? The mass. And what distance will be from here to the center of mass? How much? 0.25. So D is 0.25 squared. This is the moment of inertia of the rod with respect to that arbitrary axis. Any question? Just to prove, so this we prove it using the definition of moment of inertia for a continuous distribution, either rod with respect to the end. You remember that I proved it. Now I will prove that this one with the parallel axis theorem. So I want to find I with respect to the end, which we know already, of the rod. How much? How much is I of the rod with respect to the end? ml squared over 3. Is that correct? With respect to the end. So I will prove this with the parallel axis theorem. So I will come here and I will say, okay, I with respect to the end is my arbitrary axis. It's not the center of mass. So what will be, according to the parallel axis theorem, what will be ICM for the rod? ml squared over what? Over 12 plus, and now we have the mass And what is the distance from the end to the center of mass? L over 2. So if I put L over 2 here, I get this. So what will be I of the rod with respect to the end? ml squared over 12 plus ml squared over 4. If I multiply by 3 on the top and by 3 on the bottom, I have a common denominator, correct? So how much will be I of the rod with respect to the end? ml squared plus 3 times ml squared, what will be? 3 ml squared over, and now I have common denominator. Is that correct? What is the common denominator? 12. What will be ml squared plus 3 ml squared? 4 ml squared over what? How much we get for the I of the rod with respect to the end? This is an application of the parallel axis theorem to prove the moment of inertia with respect to the end. So we prove it both ways, using the definition, this definition, the integral I, the integral of r squared dm. Originally we proved it this way, and now we apply the parallel axis theorem to prove it again. Any question on moment of inertia? Generally speaking, I will give the moment of inertia. I will give the moment of inertia. Sometimes you need to know how to derive the moment of inertia of the rod, the ring, usually. But I usually will give the moment of inertia. So you don't have to care about that. Use the moment of inertia. So, any question on the topic moment of inertia? Okay. So, now we go, and you go to question here, go to the study guide, and go to question number 9. All right. So now